Hello microeconomics students. I want to just offer a little bit of additional help with this chapter homework because this concept of elasticity is challenging and then the calculations become a little bit harder to see sometimes. So let me go through number 3 with you as well. Even though the calculations aren't any different than the others, they might be a little harder to see because you're asked to pull the numbers out of the article. So let me help you out with this one. This gives you some information about a tax increase from 287, or excuse me, from 87 cents a pack to 287 a pack, and then it asks you to recognize that there's going to be a change in quantity demanded. So I'm going to kind of skip through this quickly to show you how to organize the numbers because the process isn't any different than anything you've seen before. It's going to use a midpoint formula. So let's go down here, and the State Legislative Analyst Office assumes a little more elasticity than the anti-smoking advocates. But it's going to they consider that the response is going to be inelastic. That's why they generally place a tax on something like cigarettes, because they figure that they can raise the price without a large quantity response. And so you'll find taxes on things like cigarettes and gasoline for that reason. For B, the anti-smoking advocates weren't as optimistic. They said it was going to be more elastic. And then down here, the calculations, I think, are where people are struggling a little bit. So let me just show you how to set this one up. They said if you assume that the price of a pack is $5 before the tax, and the actual price elasticity is 0.8, well, you've got some information to work with, and we can just work backwards. So before the tax, the price was $5, and before the tax increase, it was 87 cents. And what they meant to say was the tax increase. So that's one thing to watch out for. Then they said that that tax had gone up by $2 a pack. So the new price is going to be $7.87. So those are the price change numbers you're going to work with. And then they give you the actual price elasticity. So what we're going to want to calculate is the piece of information we don't have. Right now what we do have is we have the actual elasticity of 0.8, and we're going to calculate the percent change in price, and what we don't know is X here, and that's what we're going to solve for. So we have one piece of information, we have what we need to get the second piece of information. Once we get that, then we just algebraically can solve for the last piece that we don't know. So let me show you how we're going to do this change in price. We're going to use the midpoint formula. So we're going to go new price minus the old, 5.87. This is that P2 minus P1 over the average. So we're going to add those two together, plus 7.87. And since we're taking average of those two, we'll divide it by 2. And from that, we're going to find that this percent change in price, after we do all the math there, is 29.1%. So I'm going to kind of shorthand it for you here. 29.1%. Now, I'm not going to do the rest of it for you because given that information, it should be pretty, I hope, pretty simple to say, well, we don't know the quantity demanded, the change in quantity demanded in percent terms, but we do know the price change and we do know the resulting elasticity. So at this point, use your algebra skills and you should be able to solve for X. And then how much additional revenue would the state take in? You can figure out at $2 per pack in additional revenue times the change in the number of packs, because that's what you're going to get from X, and that's going to be a percentage change. So you can look at the 800 million packs a year, multiply that times the percentage change, get the number increase, multiply that value by $2, and you should have your values there. All right, so that's one that was a little bit tough. And let's see, the next one I set up here. This one says, suppose consumers buy 50 million packs of cigarettes per month at a price of $5 per pack. If $2 tax is added to that price, then you'll do the calculation of the price change. And you'll do the exact same thing. And you've got the price elasticity here. You're going to work backwards and set it up. And so here's cigarettes. You've got the price elasticity at 0.4, which tells you that it's inelastic response. So we're going to say, well, we've got the new price. The price change is what we're looking for. And we know that the 50 million packs of cigarettes a month is being sold at $5 per pack. So let's calculate the price change, and then we can get the quantity change from that too. So the price change from $5 to $7 is going to be pretty basic here. We're going to go 7 minus 5, right? The new price minus the old price over the average. So we're going to add 7 and 5 divided by 2. And so from there, it's pretty easy to turn that into a percentage change using this midpoint formula. So the answer that goes there is simply that calculation from this. From there, then they ask you to know what the change in cigarette sales will be. And that's going to be the second part of this, where you're going to take what you know. So you have your elasticity calculation here. So you're going to say, well, whatever the percent change in price is here, that's going to go here in the bottom of this side of the equation. Then you have your calculation of 0.4, and you're going to solve for x. So this one's quite similar to the previous one. I think the trick is finding where to start the calculation. I think that's what is quite challenging at times. And the same thing here, how much will sales decline in the long run? And if they give you a number and a percentage, you do, I think, a pretty basic calculation there. Let me show you, I think there was another one. This is going to be another one where you work backwards. And so these calculations, you know, at first they might throw you, but then when you just see that it's pretty simple algebra. You have some information, you need to find something out. So if you set it up that way, I think you'll find it pretty manageable. So in this case, we're talking about income elasticity. And so here's the formula for income elasticity. It's percent change in quantity demanded in response to the percent change in price, or excuse me, in income in this case. Sorry about that. Not price, income. And we've already been given the income increase of 23%, so that's going to go on the bottom. We don't know how much. That's the question we're going to answer on top, the percent change in quantity. And we have that income elasticity calculation of 3.29. So this becomes a process of solving this algebraically. And what you can probably see is you do, to get that out of the denominator, you multiply both sides by the same thing, and voila. Should be pretty manageable. Don't forget, when multiplying by a percentage, you move that decimal 2 places over to the left. So watch out for that. Let's see. 11 is a simple calculation of elasticity. So the price elasticity of supply, and you're going to use the midpoint formula. And you've already got part of the information, and you'll find the rest in the problem. So you've got the price increase of 20%. That's going to go on the bottom, and it's already given to you in percentage form. And you're calculating the price elasticity, so that's the piece we don't know. And then in the top, it's going to give you the quantities. So let's say that this is going to be, it went from 2,000 to 480 in 2016. Then it's between 2016 and 2017, so watch out for the years here. And then it went from 480 in 2016 to 762. So we're going to take that midpoint formula to calculate that change from 480 to 762. So we're going to take quantity 2, which is the new quantity, 762 in 2017, minus the 480 over 480 plus 762. And we're taking the average of that, so we're going to divide that quantity by 2. And once we have that on the top, we do a nice simple calculation to get the elasticity of supply. So setup is probably where you might be having some challenges. And then this last one, 13, the last one I'm going over, is another very straightforward midpoint formula calculation. So we're going to go Q2 minus Q1 over Q1 plus Q2. All of that, oh, by the way, quantity divided by 2, that's the average. All of that over P2 minus P1 over P1 plus P2, that quantity divided by 2, and that's it. So in this one, you're given the first and second price, and the first and second quantity. So just plug those values in and you're going to get a result, and it's going to be price elasticity of demand, so you're going to get a negative. You're going to take the absolute value. So when you're writing your answer in, you don't need to put the negative. Just write your response in terms of absolute value, and you should be pretty fine. This is just a calculator problem. So I hope this is a little bit more help that gets you through this last little push. In response to this request, though, I will say this. I would strongly encourage you next week and in the future, when it's challenging material like this, to start early in the week and just take it a little bit a day. And you'll find that you're going to have a much easier time. Trying to learn this in a hurry at the end of a week is you probably know, very, very difficult and probably not even possible. So I wish you the best, and